For our project, we'll be using an energy lens to observe the change in energy as a person swings back and forth on a swing set. Swing sets are designed to allow users to increase their rotational kinetic energy by gradually increasing their potential energy as they increase their height with each swing. When we swing our legs up at the end of each swing, we are gradually raising our center of mass and our gravitational potential energy. We hope to see that the gravitational potential energy is similar to the rotational kinetic energy. We will calculate the gravitational potential energy of the person at a certain height during the swinging motion. We will then find the angular velocity of the person on the swing and use that information to be able to find the rotational kinetic energy when the height of the swing is at its lowest. We hope that the gravitational potential energy at the swing's highest point will be similar to the rotational kinetic energy at the swing's lowest point.
Now that we have our measurements, we're going to calculate the potential energy first and then compare it to the rotational kinetic energy. The gravitational potential energy can be calculated by multiplying the mass of the system by the acceleration caused by gravity and the height of the person on the swing set. We calculated the mass of our system by adding the mass of Brandon and the mass of the swing set, which came out to about 70 kilograms. We let gravity equal 10 meters per second squared. For our height, we used the distance from the ground to the height of the shoulders as our height in the calculation. We found that the gravitational potential energy at that moment was 1,008 joules. On to the rotational kinetic energy calculation. We calculated the rotational kinetic energy by multiplying the moment of inertia of the person swinging by the velocity recorded using the iPhone's accelerometer. The moment of inertia is equal to the mass of the system multiplied by the radius of the swing set squared. We then multiplied the moment of inertia by the angular velocity of the person swinging when the swing reached its lowest height and its greatest kinetic energy. We found that the rotational kinetic energy was about 918.8 joules. The two energies were similar, but not exactly the same. Thank you for watching.